Hi everyone, thank you for joining us today. Today I will be your moderator, and please feel free to post any questions you have in the Q&A box. I will monitor them during the presentation. Today we will talk about being happier with Kotlin, which is presented by Andy from the MITRE Corporation. Over to you, Andy.
Thank you very much. All right, let me share my screen so we can get the presentation up and hopefully everyone can see it. Can you just verify, Lillian, that folks can see the screen?
Yes,
we can see it.
Okay, great. So, hi everybody, my name is Andy Gregorowicz, and today we are going to talk about being happier with Kotlin. So I am a principal software systems engineer at the MITRE Corporation, and I've been working as a part of the FHIR community for a good long time here. And in this particular session, there's three real main objectives that that I want folks to understand, to take away from this session. The first is we're going to talk about Kotlin and how that fits into a Java environment. So one of the things that I hope you'll learn from this talk is that you don't have to throw away the work that you're already doing if you're a Java developer. The next part is talking about HAPI, which I'm assuming most folks who are attending this talk are familiar with, and how we can extend that HAPI, which is the Java-based reference implementation of FHIR, so that you can have it so it's a tool that better suits your needs. And then finally, I'm going to discuss how Kotlin's specific features fit really, really nicely with working with FHIR resources. So since we're at FHIR DevDays, I'm assuming this is a crowd mostly of developers who are often writing code to process FHIR resources. And so I'm going to talk about how you can use Kotlin to address some of the common cases that you run into when you are working with FHIR. Oops. All right. So as FHIR developers, as I just said, we often create code that handles FHIR resources. And our code needs to be able to do three things oftentimes. One is we need to be able to work with optional data elements. FHIR resources have a lot of optional data elements. We need to be able to process data elements that may be different types. And FHIR resources have data elements that are often deep. Some of the types are complex, and we need to reach into those to pull out the information that we need. So when we're working with FHIR resources, most Java developers, I'm assuming, use HAPI. I mean, obviously you can take the, use Java and use a JSON parser or use an XML parser, depending on what flavor of FHIR you're working with to process resources. But I'm assuming that most developers that are working with Java use HAPI, which is the reference implementation of FHIR written in Java. And HAPI does a nice job. It provides Java classes to represent the FHIR resources. So if you have an encounter resource, there is an encounter class that you can use to handle that. And these classes are great, but what happens is Java sometimes can get in the way of our happiness. I personally find Java to be a very verbose language. It oftentimes asks you for information that it should kind of know already. And so that can be kind of a downer for some of us that are coming from other languages that are perhaps a little bit more expressive or give you a little bit more freedom. So it would be nice if there was a toolkit that we could use to maybe increase our happiness while still working with this great HAPI API. So my argument in this talk is that Kotlin is one way that you can do that. So for folks who don't know about Kotlin, it is an open source programming language. It was announced by JetBrains, that is the company behind the IDEA IntelliJ IDE. They announced this way back in 2011. It is an open source programming language. It's available under the Apache 2 software license. So it's free, and you can download it and incorporate it in your projects under a business-friendly license. And one of the really important, well, two really important things to know about Kotlin is that one, it runs on the Java virtual machine. So it can invoke existing Java code, and it can also be called by Java code. So this is not a radical departure from some of your existing technology if you are a Java development shop. In fact, you can be handed off typical artifacts, jar files, war files, whatever that could contain Kotlin, and run them in your existing environment and not really know the difference. Another reason why I advocate for using Kotlin is that this isn't some weird academic language that isn't going to have any traction and it's just employed by language nerds like myself. Kotlin is now Google's preferred language for Android development. So obviously Android is a huge platform. Google being a large, important IT company throwing their weight behind it. So this, I don't see Kotlin going away anytime soon. I see this as a language that is growing, that a lot of developers are learning. And if you are in a project management type capacity and you need to find Kotlin skills, I see this as a place where you will be able to find developers who will have this skill set just by virtue of there being a lot of Android developers out there and the interest in Android causing this, this particular skill set to grow. So as I mentioned, Kotlin is a language that you can use to mix into your existing Java projects. So you don't have to start over. If you have a Java project that is working with FHIR, you don't have to throw away any of your code. You can start using Kotlin today and keep all of your code in place. My slides will be uploaded later today, so they'll be attached to the talk. All these links work, so I've provided links for how you can use Kotlin in your existing projects if you're using IntelliJ IDEA. There's also tutorials here for how to work it into Gradle projects and Maven projects, so you can just click through and follow those links, and that will allow you to start putting Kotlin files into your existing Java projects. And you could, start with Java, but then move into Kotlin for any new functionality that you're building. And it's important to note that, again, Kotlin can call into Java. It can be called from Java. And so Kotlin applications can use existing Java libraries. Again, this is very important. You don't have to wait for a whole new Kotlin ecosystem to evolve. So you can take advantage of many Java libraries, and including, obviously, the HAPI library. So you can be working in Kotlin with HAPI right away. You don't have to wait for a Kotlin specific FHIR API or just work with the plain FHIR JSON. You can use HAPI to start building your Kotlin projects. So my argument is that Kotlin can make you even happier. So the HAPI library, in my opinion, is great. It's a great reference implementation. It does pretty much everything that you need to do and more with FHIR. But my argument is that Kotlin makes it even easier to work with. And so the rest of this presentation, what I'm going to walk through is some examples that I extracted from a real world project that I was working on at MITRE. And the code samples that I pulled out of this project are to show you places where, in my opinion, Kotlin really shines when working with FHIR resources. This talk isn't going to be a deep dive into Kotlin syntax. I don't think that's particularly helpful. And that's something that you can certainly learn on your own time. I wouldn't consider myself a Kotlin expert by any stretch. I'm sure there are many folks who are very clever with Kotlin, but view this as a developer who needed to write some code and decided to pick up Kotlin. And these were the gems that I picked up and found to help me be really, really productive from sort of a high level conceptual perspective. And I'm really hoping to whet your appetite so that after this talk, you'll, the next time you need to write some Java code to process some FHIR, that you'll hear my voice in the back of your head and maybe think about pulling Kotlin into your project to take a stab at things. So with that, why don't we dive in? So as I mentioned, we have FHIR choice types. So this is something that you come across in FHIR resources. And what I'm showing here is an example from the observation resource. So observations have values. You can have value quantities. So that's you have the value data element. It's a choice type. A value quantity might be something like if you're looking at a lab result, like an LDL cholesterol. That would be a floating point number with a unit, or it might be something like a value codable concept. So it might be that a test result is positive or negative, or something like that. So this choice type means that you can have different types, Java types or Java classes being returned when you are pulling this information out of an observation resource. So if you have Java code that needs to handle pulling information out of an observation and you need to look at the value, you need to anticipate that different types will be coming out of that. And my argument is that the Java tools for sorting this out are kind of verbose. And that's where one of the Kotlin features, or two Kotlin features, sort of combine to show off their superpowers and make your life a little bit easier. And that's Kotlin switch cases and smart casts. So first of all, Kotlin allows switch cases to be based on the class of the variable being tested. So in Java, Java case statements or Java switch statements are fairly limited in what you can switch on, but you can actually switch on classes in Kotlin, and we'll walk through an example so you see what this looks like. And this avoids, when I've had to write this code before in Java, if I was going to pull out a value from an observation, typically you have to do a bunch of if my variable is an instance of codable concept, then do whatever else. If it's a physical quantity, do this. So in this case, you can avoid all of that by just writing a switch case on the, saying on this value, I want to switch on this. And if it's a codable concept, if it's a physical quantity, do that. Kotlin also has this notion of something called a smart cast. And a smart cast, what that does is Kotlin saves you a lot of times from telling the compiler things that it should already know. So if you're in a switch case where you've switched to say this is a physical quantity, you don't have to cast that variable to a physical quantity. It typically saves you a line of code where you say, if this variable is an instance of physical quantity, and then the next line down, you say physical quantity PQ equals, cast whatever that variable was into a physical quantity. So it saves you a line of code there. And I'm going to show you on the next slide an example of what that looks like when we're getting where we're getting the value out of an observation. And so this is some actual Kotlin code. And I'll walk through this. So you can see on the first line, Kotlin for our switch statement uses this when, and we pull out our observation value. So this is a HAPI observation class that would come from a FHIR observation resource. One of the nice things about Kotlin is that you don't have to worry about getters and setters like you do in Java. It will call the getter under the covers. So this is the same as calling a observation get value if you were using the Java version of HAPI. And then you can see I can switch on the class. So I can say when this is a quantity, I want to do this. And you'll notice that I don't have to cast this into a quantity. Now it is treating that observation value as if it were a quantity class. And then the same down here with codable concept. Now I can see that this is a codable concept. I can go and look through the coding. There is some other Kotlin niceties that are going on here where basically I can grab the first coding out of there, and I'm doing some work here to see if it's a SNOMED code, and if it is, I grab the code to do some further processing. So this was a nice case that I discovered here with Kotlin that I thought made my life easier. I was processing a bunch of data that was coming in from FHIR. Some of these were going to be observations, such as LDL cholesterols or things like that. Others were coded concepts such as positive or negative. I don't recall what they were exactly off the top of my head. And so this was just a nice, concise way of doing it that replaced the if else's you would have to do on instance of, and the casting that you would typically have to do once you have that variable. So next, again, for those of you who are processing FHIR resources, many of the data elements that you work with in a FHIR resource, they are optional. I'm giving you a clip here of the observation resource, again, in FHIR. And this is just a plain observation resource. There aren't any profiles applied to it. But the thing that you should notice here is that if you look at the cardinality what you will find is that most of them essentially say that it's optional, that it's 0 to star or 0 to 1. So when you are working with FHIR resources, you really need to be prepared to handle null values or missing values. That's just something you need to be aware of, unless you really want your code to crash with null pointer exceptions and whatnot. So you need to be prepared for that. One of the nice features that Kotlin provides for you is it's really strong on null safety. So the first part, or the first thing that I'll talk about, is that Kotlin has this notion of safe calls where you can use question mark. It's sort of like an operator, and it'll return null and skip subsequent method calls. So for those of you who might be dealing with a FHIR observation that is conforming to the US core vital sign for blood pressure, you have to look through that observation to dig through to get to the component, and that component's going to have the value quantity, which is going to have a value, which eventually you're going to want to wind up doing something like casting it to a float. And you can see here, I can actually use, and we can get into a whole discussion on whether you really want to do train wrecking like this and smashing all these method calls together. But let's set that aside for the moment. You can see here I'm providing this question mark. So if the component's not present, the Kotlin code would actually stop executing here and return null. But if it is present, it'll move on to value quantity, so on to value, and so on to float. So that allows me to dig all the way into this particular FHIR resource and not really have to go through and say, okay, if component is not equal to null, then give me the value quantity. If value quantity is not equal to null, then give me the value. If value is not equal to null, give me the float representation of that. I can just briefly do that on one line and be sure that my code's not going to crash if for some reason I have a weird resource that leaves some of this information out along the way. One of the cool things about Kotlin, or at least in my opinion, it's cool, is that Kotlin actually differentiates between nullable and non-nullable types. So when you look at Kotlin code, you will see things like string versus string with a question mark on the end of that. And what that means is that if you see a string type in Kotlin that's saying that string will never be null, you are guaranteed that that string will always have a value assigned to it. If you were to do something like string foo equals null in Kotlin, the compiler will not compile that code for you. It will return an error. And you have to work, if you have something that can be null, you have to execute the appropriate Kotlin code to make sure that you get a value back, that it will be assigned an appropriate value, or your code won't compile. So it's really nice that for the most part, and there are ways to get around it. Kotlin will let you shoot yourself in the foot if you are so inclined. So it will get out of your way. But for the most part, it really does provide guardrails for you so that you will not run into nullable types, or you won't run into a null pointer error as you're processing different resources. Another really nice feature that we have in Kotlin is this notion of extension functions. And what Kotlin allows you to do is classes can be extended without inheritance through this mechanism called extension functions. And what that allows you to do is you can kind of hang these functions off the end of existing classes. Again, you don't have to subclass them. And we can do that with our HAPI classes, which is really nice. So we can do this first for convenience, or second to support a particular FHIR profile. Again, this is really nice. The typical way that you would go about something like this in Java is you could perhaps create a subclass of a particular class, but that doesn't often work that well. Because if you are working with something like HAPI, you get a JSON document in, you parse that JSON document, it returns to you a bunch of instances, but now those aren't in the subclass that you want, so you'd have to pass it through some other function to wrap them with some sort of facade, or to put them into the subclasses that you've designed. In this case, with our extension functions, we don't have to go through all of that. We can define these extension functions, they get put onto those instances, and we can use them right away. So we can define some convenience functions, or again, if we know that we're working with a particular FHIR profile, we can actually build out functions so that we have nice convenience methods we can use to work with resources that conform to a particular profile. So let's talk about what that looks like. I'm sure that if you're a FHIR developer, you have come across codable concepts. You know, they can sometimes feel really repetitive if you have to work with them. Oftentimes you're expecting a single code and a single code system that comes back, or you just want to check and say, like, is this code in this concept? So this is an extension function that I wound up defining in the project that I was working on. So I have this thing called contains code, which returns a Boolean. And what I can do is I can pass in a code and a code system, and it will check a codable concept to see if that code and code system are present. What's nice is once I define this function in my project, I can import it into the Kotlin code that I am working with. And now all codable concepts that that exist when I'm parsing something and working with HAPI objects, they will now have this contains code function. So again, I didn't have to wrap them in any sort of weird facade or anything like that. I just need to import this function into my file. The other thing that's really cool about this is notice that I define this on codable concept question mark, not just plain old codable concept. And Kotlin extension functions are really cool in that you can see they wind up defining this, which you can actually check for null. So what that really boils down to is that even if I was working with a FHIR resource and it's supposed to have a codable concept, and that codable concept wasn't provided, so it would be null, this function can deal with that. So it would actually say this equals null, and it would just return false. So again, this is something that's really nice where the null safety can play into your extension functions. So now I don't have to do, you know, if I'm ripping through a set of FHIR observations and I want to look for a particular observation that is coded in a particular way, I don't have to say, okay, if observation.code, I forget if it is observation code, but I don't have to say if it's not equal to null, then go and iterate through all the particular codings to look for a particular code. I can now just say contains code, and if that observation code was null, that's still fine. It's not going to crash because this code is built to handle it, which I find to be really, really nice. And again, as I mentioned, you can extend different HAPI classes to fit a particular profile. So again, US core, if you're talking about US core vital signs, blood pressure, you can see here I extended the HAPI observation class here to obtain the diastolic blood pressure. So now any observation that I pull in, I can ask it for the diastolic blood pressure. It will go through and see if it contains that particular code. And if it does, if the observation has a component that contains that particular code, and if it does, it will go through that component to find the float value in it, which would return to me the diastolic blood pressure. And again, you'll see I have to be careful because this is returning a float question mark. So that means that you know, if I were to execute this on a component that does on an observation that doesn't have that particular component, that's fine. This will return null, but Kotlin is letting me know that, hey, you need to be careful, that could return null, and so your code has to be prepared to handle that. But again, this is really nice because now I have observations that I can treat in a way that works with my profile without having to necessarily wrap the class or anything like that. All observations have this function now associated with it. And if you are a developer, odds are you've also had to work with FHIR bundles. And in the project that I was working with, for many of you are probably familiar with Cynthia, the synthetic patient generator. Cynthia out of the box will return FHIR bundles that are a lot like the bundles that you will get from a patient everything operation. And so they essentially create, it creates a FHIR bundle that looks like, that has all the observations, conditions, the patient resource, everything like that, that you are interested in about an individual. So when you're looking at that, you might want to scan through the bundle for a particular resource type and do some work on that kind of resource. You could, for instance, you could scan through the bundle looking for all the conditions to do something like build a problem list, or in the case of the work that I was doing, I wanted to scan through and find all BMI observations so I could build out sort of a trajectory of BMIs for an individual over time. So what I'm going to show you here is, again, how the power of Kotlin can combine. We're going to use Kotlin lambdas, extension functions, and smart casts, so that we can use that to combine nicely to kind of go through a FHIR bundle and use that to extract BMIs that we can work with. So this is what the code looks like. We have a bundle that we've pulled in from FHIR. We have this bundle is going to have entry, which is going to include a list of bundle entries. Kotlin has this filter function, which I can pass a lambda to. If you're familiar with Java and Java 8, the lambdas are kind of similar. One of the cool things about Kotlin is it has this default parameter. So if you have a lambda that just takes a single parameter, you can always just call it in Kotlin, and it knows what you're talking about. So this it is a bundle resource entry, or is a bundle entry, and I can grab the resource out of it. So what I'm saying is filter this down to just observations. And then I'm using this map operation here that is going to grab the resource out of here as an observation. So now I have this list in Kotlin that actually is just a list of all observations. And what you'll see is nice here is when I get down into the next operation that I wanted to go through here to pull out the BMIs, I can do a filter again. Now it knows that this is actually a list of observations, so I can just call into code, and I built an extension function onto Codable Concept that was similar to the extension functions that I was showing previously, where I have this first loink code, first loink code extension, which will just return to me the first loink code. So now I can filter this down. So when I look through my list of observations, I'm looking for the loink code here for BMI. So I can filter it down, and now I just have a list of the BMIs from this FHIR bundle. So what we're showing here is that in a couple of lines of code, I can pull in a FHIR bundle, winnow it down to just the observations, and then using an extension function, I can process those observations pretty quickly down to just the BMI observations. And so that's pretty handy, at least in my opinion, to be able to go through and pull out that type of information. So hopefully from this talk, what you've been able to learn is that you can start using Kotlin in your existing Java projects. Again, these slides will be available. The links in this presentation are clickable so that you can go through to figure out how you can use Kotlin in your existing Maven projects or in your existing Gradle projects, or if you're using an IDE, there are ways to just jump right in and start using Kotlin right away. So you can mix those in. You don't have to wait for a whole new project. You can start using it right now on your existing project. Hopefully what you've seen are that the language features make handling different aspects of FHIR resources easier than just plain Java. They're less verbose. You don't have to worry about null pointer exceptions in as many cases. You don't have to worry about checking types as much, or you can handle that much easier. You can use Kotlin to extend HAPI for your particular use case. So you're seeing some particular instances for the code that I was working with. But again, depending on the profiles that you're working with in FHIR, you can build your own set of extension methods so that the HAPI API works better for you. And so with all that, I would argue that if you use Kotlin, you will wind up being happier. During DevDays, you can reach out to me. I'm in the speaker gallery. Please feel free to shoot me an email. And with that, I will take any of your questions.
So thank you, Andy, for a very interesting presentation. I can imagine that it will make your life a lot easier using Kotlin. No questions came in so far. So everyone, if you have any questions, please post them in the Q&A box. And also the Q&A will still be available after this session. So if any question still pops up, just put them there and Andy will check that. In the meantime, we will wait if there any questions still come in. In the meantime, I have one question, because you talked a lot about all the advantages. But maybe you can also say something about, is there anything still missing in Kotlin that you would like to be able to do that you couldn't do with Kotlin?
That's a good question. You know, I think right now there wasn't anything that I found in Kotlin that I wasn't necessarily able to do. You know, I think it's going to be more a matter of it still is relatively new, especially to a language like Java that has been around now for quite some time. So you know, finding support for it and things like that, it's going to be it's a less mature technology. So that's that really seems to be the drawback to it. That being said, you know, this is not you know, an immature technology. It's certainly it certainly has a lot of support, and I think there are a lot of upsides. But when you compare it to the full, you know, sort of the full Java ecosystem, and you know, the just how long it's been around and the resources you can find for Java, it's certainly not there yet.
Okay. Well, we don't have any questions so far, so I think you have had a very clear presentation. Is there anything else that you would like to share with us, or?
Not that I can think of off the top of my head. Again, I hope this this you know, sort of whets your appetite, and that you will be you know, interested and download it, and you know, want to play around with it. Although I see Graham has raised
there are questions coming in, so
okay,
we'll just need it some time. Which is the smartest way to handle extensions?
What is the smartest way to handle extensions? That's a really good question. The way that you know, I'm still getting my feet wet with this, so I don't necessarily have any particularly great guidance on you know, best practices. But I can tell you what I did in this particular project is that I created a Kotlin package for all of my extension functions. And then I organized them by the particular resource that they were working with. So for instance, I had an observation extension, essentially an observation extensions file, an encounter extensions file, things like that, so that it was pretty clear, bundle extensions, so that all of the extensions for a particular class were located in a particular file, and all of those were confined to a particular package. So that was a strategy that I used, and that seemed to work relatively well. So take that for what it's worth. Your mileage may vary, and I would encourage you to, you know, find your own best practices. But that's how I attack the problem.
Another question from Graham. He writes the HAPI classes, and he defines a number of utility functions in Java that would naturally be good extension function in Kotlin. Is there any way for that to happen automatically?
I don't know if there's a way to do that automatically. I mean, when there are utility functions in Java, you know, those utility functions are still, you know, those are still available to you in Kotlin, because you can just call any Java functions from Kotlin. So, you know, if there are any HAPI functions that you find convenient that you want to use, those are all available to you, and you should just continue to use them. There's not necessarily any need to redefine those. Now, that said, they may be more useful as extension functions, and so that might be something worth looking into. What I will say, and I didn't go into it too deeply in this talk because I thought it was a little bit too far into the deep end, but Kotlin's facilities for metaprogramming, sort of generating code on the fly, are a lot stronger than what is available to you in Java. And it has support for some really cool stuff, like you can deal with the type erasure that you run into with generics. They have this whole type reification piece that you can use. So if there's a particular case that you're interested in and you might want to generate some extension functions, automatically based on some functions that are already there within HAPI. Kotlin may be more amenable to that than what you would get out of typical Java metaprogramming. I'd have to drill into a particular case. So I'm being a little bit hand wavy here, but I think Kotlin would be a little bit more suitable to allow you to generate some of that code.
Then a follow-up question. Is there any chance you would want the HAPI classes to make something easier in Kotlin?
That's a good question. I really didn't have it. My beef necessarily wasn't, or if there is a beef to any extent. I think HAPI does what it can with as best it can in Java. It's that sometimes Java makes it a little bit harder to work with things. So again, when you're dealing with choice types in FHIR, HAPI has to return a pretty generic type for you to work with, and then you have to sort of lead Java along to cast it appropriately. Maybe some way that I guess before I started working with Kotlin, one thing that I thought would be nice in HAPI, although I think it would get kind of verbose and messy, is when you have Java choice types, if there were sort of a convenience method that would allow you to say, get type codable concept, or something like that, where it's sort of automatically generated out all the particular types that it could be. Again, I'm not even sure that's good API design. That was just something I sort of thought of in the moment, being a little bit frustrated that I would have to go through and do all this casting work when I knew the observation under the covers was always going to be a codable concept, or always was going to be a value or physical quantity or whatever. So I guess that's the only thing I could really think of off the top of my head, but that's not even a suggestion I would encourage someone to act on, because it might lead to a sort of messy API design.
Thank you. Have you found any parts of HAPI where using it in Kotlin required extra work?
No, I haven't. The Kotlin Java API bits seem to be pretty well tested, and HAPI worked. HAPI is a Java library, and the Kotlin Java API stuff is pretty good. So I didn't run into any extra bits where I had to do extra work. I think there are, there are some things that you could go through to make the Java Kotlin integration a little bit smarter. I didn't dig into that, so it would certainly be possible for HAPI to do that. But again, I didn't do any additional work. I found that I was just able to use, just add the HAPI library to my Gradle dependencies in my Kotlin project, and I was off and running.
Then the final question that I have at the moment, what barriers to entry can we anticipate and address? For example, I work on a large team, and I need to make sure that my Kotlin code can be maintained, supported by other developers. And we also need to hire new developers.
Sure. I mean, that's going to be the most difficult aspect to this. So, obviously, if you want to integrate Kotlin into a team, there's going to need to be some sort of training process that's associated with it. And again, the piece that I would advocate for with using Kotlin is that it doesn't have to be an all or nothing approach with Kotlin. So it can be integrated with your Java code. You can have projects. The tutorials that I linked to will show you how you can have Java and Kotlin code living side by side. So if you are working on a larger team, what I would encourage you to do is start to fold this into an existing project. As with any sort of team dynamics, you probably want to, draw some boundaries and say, hey, we're going to use Kotlin to implement this particular feature. Maybe you decide as a baby step, you want to try it out. Again, it's something that you can try safely so that you can You might implement a particular feature in Kotlin. It could live in your Java project. If you decide you don't like it, that's fine. You can always throw that away. Again, you'd have to write it again in Java, but it's not going to be a far cry if it's in Kotlin. But you'll have to come up with some boundaries to discuss with your teammates, and then figure out how much you would want to put in Kotlin. I certainly hear the notion that you're going to have to hire developers. And again, my thoughts on that would be, one, I'm not going to make an argument here that Kotlin skills are going to be as easy to find as Java developers. There's obviously a huge pool of Java developers out there, and it's certainly larger than the pool of Kotlin developers that are out there. That said, the argument that I would make is that now that Google is in the position where they have declared Kotlin to be their preferred language for Android development, that we are going to that we're going to see the pool of Kotlin developers expand, and that Kotlin will be a more common skill set amongst developers. I think driven by the Android development community, driven by that Google support, and by the support that you see in Kotlin in a lot of things that are sort of familiar to Java developers. So IDEs support Kotlin and whatnot. So you can really you can really transition Java developers over very, very gradually. You're not asking them to start in a new IDE or with new build tools. If you're working in something like IntelliJ or even Eclipse, you can use your existing Gradle or Maven builds, and you can just start to integrate your Kotlin files right then and there. So I think that it's a pretty welcoming environment, and you can have a very, very slow and gradual transition over to this technology. It's not like you have to flip a switch overnight.
Great, thank you, Andy, for a very interesting presentation. That's all the questions we have. And we are also nice in time for everyone, please join us at the FHIR Islands for some socializing. And also please rate the presentation in the app so we know what you think about it. And thanks for your attention, everyone.
Thank you very much.